7.2.
7.2.
So, okay, let's do that. 7.2, more elimination. Just have a couple of examples to show you.
Two more elimination.
More elimination.
Oh, that's a high. Okay. Looks like I have. Whoa. Elimination.
If you, let's try this. We have 3x plus 2y is equal to 4. We have 5x minus 2y is equal to 8. Solve for x, or solve for x and y. What do you see that happens right off the bat?
The y's cancel.
The y's cancel out. So you're going to have 8x equals 12. Divide by 8. Divide by 8. So x would be equal to 12/8, which is, I'm having deja vu right now. Didn't that happen yesterday?
Yes, it did.
Yeah.
Alright, so now what we need to do is figure out the y. So I'm going to go take this x, plug it back into, I'll put it into the first equation. So we're going to have 3 times 1.5. Did we do this exact same example yesterday?
Yes.
Yes.
Okay, hold on. There's a reason I'm doing this. I didn't realize it was exactly the same example. But 3 times 1.5 is 4.5 plus 2y is equal to 4. Subtract the 4.5.
You get a negative 0.5. What is that?
Subtract 4.5. They cancel out. 2y is equal to 0.5.
Negative 0.5. Negative 0.5.
Negative 0.5, thank you. So y is equal to negative 0.5 divided by 2, which is negative 0.25. So we have a solution at 1.5 comma negative 0.25. This is what we call
Ordered pair.
an ordered pair, yes. But because we got an answer, it's called a consistent solution. Why? I don't know. Fancy name for getting an answer. It's a fancy name for getting an answer, so. Alright, but we're going to talk about what happens if you don't get an answer. We have a couple of things that could happen. So when you graph these lines are going to intersect each other. And they're going to create a point. That's the point right there, 1.5 comma negative 2.5. Alright, so but we could have situations when two lines don't ever intersect each other. What happens then? If two lines never intersect each other, what does that mean? There's no solution. If they don't cross each other,
They're
then you
probably
can't
parallel.
find.
Actually, they are parallel.
Yeah, they are parallel. They're parallel, which means they don't ever intersect each other. So what happens if you have a problem like that? How is your solution going to look? That's what I want to show you guys. So let's try this. 2x. Let's try this. We have 2x minus 3y is equal to 3, and negative 4x plus 6y is equal to 6. That is the solution. Let's solve for x. Or solve for x and y. What can we do?
Maybe divide the bottom equation by -2.
Divide the bottom equation by -2. Would that work?
No.
Multiply the top.
Oh, I know what's happening. Oh, wait, no. Never mind. I give up.
We could just multiply the top one by
2.
2. Yep.
I thought the equations were the same and they're parallel.
It will be when you multiply by 2.
Oh. Oh.
No, wait. What is it? When they're parallel, they're not the same equation.
Well, they're opposite.
Multiply by 2.
Okay. Oh, they're opposite. I get it.
So we have 4x.
Glad.
We have
Plus.
negative 6y. We have 6.
Oh, that's a negative 6.
Still with me?
Yeah.
I'm going to rewrite the second. Negative 4x plus 6y is equal to 6. What happens to our x's?
Cancel out.
What happens to our y's?
They cancel out.
Cancel out. What do we get over here?
Cancel out.
1. Hey, that was supposed to be in the negatives.
We have nothing over here,
So no solution.
and we have a 12 on the other side. Is this a true statement? Does nothing equal 12?
No.
So if that happens, you have no solution.
Stupid answer.
Oh.
Which means
Okay.
that the lines would be parallel. So let's just look at how,
How did that happen?
well, if you were to solve for y in each one of these original equations, you're gonna get well, let's just run through this one right here. You're gonna end up, and I'm not gonna go through all of the math, but we're gonna have 3 minus 2x divided by negative 3, which is actually going to get me negative 1 plus 2/3 x. If I do this one, I'm going to have 6y equals 6 plus 4x. I divide by 6. That's going to get me y is equal to 1 plus 4/6 is 2/3 x. What is the difference between that equation and that equation?
It's negative.
The one's a 1 and one's a negative 1. So that means they are exactly the same line, except that one has a y-intercept at negative 1, one of them has a
So they're
y-intercept at
2
1.
units apart.
So they are 2 units apart. So if you graphed them on the x and the y coordinate plane, you're going to have one line down here. You're going to have another line with exactly the same slope, which is why they don't cross each other. It's just going to have a different y-intercept. This one crosses at 1, the other one crosses at negative 1. Does that make sense? So they're never going to touch each other, which means they're parallel, so therefore there is no solution. There's one other situation that could happen. We could have lines that touch each other, cross in one spot. We could have parallel lines, which means they never touch each other. What else could happen?
Perpendicular.
Well, if they're
One and
perpendicular, so they still cross in one spot.
What if they're
What if
waving?
they're right on top of each other?
What if they are right on top of each other? That's the
Well, then that's stupid.
If they fall, what if you, in other words, you have a line and you have another line right on top of it, but by looking at the equation, you can't tell that it's exactly the same line. So you
Yeah,
go
you
through all the
should be able to.
steps.
Blam.
You go through all the steps and you come out with something at the end. That's what I want to show you. If you come up with a certain situation at the end, that's going to tell you that you have a line right on top
So
of
would those
a
equal
line.
the same? Would those equations be the same? Like, would they end up being the same?
Yes, they would be. Yeah, if you were to go through and solve for y, you'd end up with exactly the same equation. But initially, depending on how they look to start with, you probably won't recognize that they're exactly the same equation.
We'll see about that.
All right, well, right. So let's do this. 2x minus 3y equals 3, and I know that's exactly how the other one started out. Minus 4x plus 6y equals negative 6.
Yeah.
That's what I thought
Yeah,
the
you
first
can.
one said.
Yeah.
That's what I said.
Did you?
Yeah.
Because the equal sign look like the
They're all opposite. You know?
Ooh, I
Yeah, they are all exact opposites of each other. Yep. But they're not. They won't always be that obvious. You know, sometimes. Well, especially if you are using. Especially if they're not set up nicely like this, where it's the x's first, then the y's, then the equal sign, and then numbers. If you have to use substitution, you might not recognize them. The equation might look very, very obscure. But the same thing will happen. If you end up with what happens here when you're using substitution, you still have the same kind of an answer. So
Okay.
what am I going to do here? If you were ignorant to the fact that you have the same line here, what do you do?
Multiply the top by 2.
Multiply the top by 2. You're going to end up with 4x
You're gonna get
minus
0.
6y is equal to 6. Second equation, negative 4x plus 6y is equal to negative 6. These cancel out, these cancel out, those cancel out. What do you end up with in the end?
0 equals
You end up with a 0 is equal to 0. Alright, so if you have a 0 equals 0, what did that mean?
That means it is
Right on top of
Okay,
equal to
what does that mean about the solutions? So we have a line,
That means they're right on top of
and
each
we
other.
have another line right on top of it.
I can't even see it.
Oh my gosh.
Wow. Are
So you
saying
have a line on
something
top of a line, what does that
See
mean about the
that?
solutions? Is there one solution?
It's an amazing
Yep.
There's infinite solutions. So
Nice.
this right here means, can I not be interrupted anymore? Done. Way too many side conversations. I feel like I can't finish a sentence without being interrupted today. 0, you have infinite solutions. You end up with this situation where 0 equals something other than 0, that means there's no solution. And then the third example, if you actually get a solution, it's called a consistent solution. 3 situations: consistent, no solution, that symbol, you guys know that means no solution. And then you have infinite solutions when 0 equals 0. Yes?
Can you use other ways of solving problems than just elimination?
Well, if it says elimination, I want you to demonstrate to me that you know how to use elimination. So on the test, I will be specific and say, show me, you know, there will be portions of the test where I will just say solve for x and y, and I won't tell you you have to do it this way. But there will be portions where I say use substitution, use elimination, okay? Because I want you to demonstrate to me that you have learned all the techniques that you're supposed to learn.